Okay, welcome back to the Dublin Academy of Maths. Now today we're Leaving Cert Ordinary Level Maths, Series 7, Episode 5, and it's the line. Okay, geometry of the line or coordinate geometry, and it's paper 2. Okay, now here are some of the questions. I'll go through these later which you will understand. This 2, 1, 3, 4, 5, 1, 3, 6, 3, 4, minus 2, minus 6, 6, 0, minus 2, 3. Okay, now I squashed this kind of up much so here. This is by translation of one of the vertices 0, 0. So you got 2, 3, 5, 1, 2, 0, 5, 1, 2, minus 3, 7, 1. Over here you've got minus 2, 3, 4, 0, 1, minus 4, 3, minus 5, minus 2, 4, minus 4, minus 1. Now that's all for the people who say they can't read the questions. Okay, now I'm going to show you how to do some of these. So, to get the area of a triangle, right? To get the area of a triangle, I need to have one of the vertices 0, 0. Okay, now what does that mean? That means that it connects. Alright, so you might have a triangle like that. You might go out this way in some way. Alright, so it could be like this. But one of the vertices is 0, 0. And there's a formula. Okay, so the area of a triangle, I'm going to use a small round difference area of a triangle, is half x1 y2. Remember that part. If you can remember that part, you can remember the next part. x2 y1, because they're not repeated. Okay, the answer will always be positive, right? Even if you get a negative answer, because anyway, we'll get to this question. So say one of the vertices there are, this is 0, 0. So it says find the area of a triangle vertices 0, 0, one of the vertices 0, 0, and the rest of the points. So the rest of the points are 0, 0, 2, 1, and 4, 3. Okay, so now you don't have any problems here, you don't have to translate, you just have to label your points. x1, y1, x2, y2. Okay? And you slot them into the formula. Okay? Not including 0, 0. So you've got half of x1, 2 times y2, which is 4. x1, it's 3, I have to 3, minus x2, 4, by y1, 1. Okay, so it's multiplication. So it's very important that you look at your points and you go back over them. Okay, so that becomes half of 2 times 3 is 6, 6 minus 4, so it's half of 6 minus 4 is 2, so you know that's 2 over 1, so it means 2 over 2, which is equal to 1. Okay, remember you're multiplying near the end. Okay? Now as I said, sometimes you will get negative answers, okay, but they must show that they're positive. And when you're answering, that last one, when you're answering, you put in 1 unit squared. That was the answer to the last one. If you have 8, now you can do it either this way, units squared, okay, or squared units. But as long as you get it in that it's area, okay, and area is measured in measurement squared. Okay, now what happens if we have a triangle that doesn't, for example, it's over here or it might be over there, and it's none of its vertices are 0, 0. So it says we'll find the area of, let's say we call this B. Find the area of B, which is the points 2, 3, minus 5, 1, and C is 3, 1. Okay, now they're all labelled. So this will be A, B, C. And it'll correspond to that. Now there's a minus 5 in it, so it's actually over here somewhere, okay? It's minus 5, 2, 3, and it's something like this, okay? Something like that. Not exactly, but you can get to see the idea that none of the vertices includes the origin being 0, 0. So now all I have to do is I have to translate. In other words, I have to bring one of these points to 0, 0, and they will all follow the same translation as we've been doing, okay? And when they follow this translation, it means that you've moved the triangle up because you've translated this. So I'm going to pick 2, 3, okay, to go to 0, 0. Alright? So if 2, 3 goes to 0, 0, what happens to the x value and what happens to the y value? Now you have to look at this. So what happens to the x? The x went down 2. And what happened to the y value? The y value went down 3. So this is I'm kind of picking the positive numbers to go to the 0, 0 because I could have picked 3, 1, but it's going to be much easier for me. Okay, so I follow the same suit. Again, x goes down 2, so minus 5 minus 2 is minus 7. Now remember that. And y goes down 3. 1 minus 3 is minus 2. Okay, that's one set of points. And you're bringing down the same here again. So you're looking at it here. So x goes down 2, so you got 1. Y goes down 3, so you got 1 minus 3 is, okay, minus 2. Okay. Now, so you're following this along with me, and these are your new set of points: x1, y1, x2, y2. And now I introduce this back into my formula given for a triangle that has vertices 0, 0. So now you've moved this triangle up here somewhere, okay? And it's holding its same shape. Everything is done proper for you because of this translation. You've done this translation here. Okay, so this is the translation. So I just lot them in, so it becomes half of, right, x1. x1 is minus 7 times y2, which is minus 2, minus x2, which is 1, times y1, which is minus 2. Okay, now I'm going to move this out of the way so you understand the translation here. So you've got to solve this again. Okay, so you're almost there, right? So minus 7 by minus 2 is 14. Minus 1 by minus 2 is plus 2. Okay? So you got half of 14 plus 2 is 16. So you divide 16 over 1. So 16 over 2. 2 into 16 goes 8 times. That's your answer. 8 units squared. Okay? And it's positive. Okay, that's great. Now, so that's how you can translate triangles. Now, I just want to write out a few things here. Now, we've got other things that I've seen is collinear. What does collinear mean? On the same line. So you have collinear points, it means they're on the same line. Okay, and they could include that in questions. Quadrilateral. Quadrilateral. A lateral or a parallelogram. Well, they're the quadrilateral, all sides are equal. Different to a parallelogram. All sides are equal in measure, equal in length, equal in length. Okay? And so we've got a quadrilateral and then we've got an isosceles. I'll get back to the parallelogram. Isosceles, 2 of the sides are equal. Okay, now 2 of the sides are equal, that means that their angles are equal. Those angles there are equal. So you be very be careful and you know all these. And a parallelogram is something that goes like this. Okay, so they're slanting, right? So this side is going to the same direction as this, and this side are the same. So in other words, their slopes, opposite slopes, are equal. Okay, and so are their sides, and so are their angles. Now this is a bit of geometry here. They're equal. Okay, opposite angles and they're equal. So there's a lot of things going on here with parallelograms, which is not really involved here, but I mean it gives you an idea what's happening. So those, remember, opposite sides are equal. Now opposite sides meaning those two sides are equal and those two sides are equal. Okay, and angles, opposite angles. Right, now, so you might have a question that says find the area of a quadrilateral. Okay, now that's a spooky one that has come up before. So find the area of the area of each quadrilateral QUAD. Okay, so quadrilateral, you're given this points 1. A is 0, 0, B is 4 minus 1, and C is 2, 3, and D is minus 2, 4. Okay. Now, you have to, so you've got this you've got a quadrilateral. Okay, so what is a quadrilateral? A quadrilateral, as I explained, has 4 sides. Okay, all equal. So that could be that quadrilateral there. Okay, but actually it's not, because one of the vertices is 0, 0. Okay, so bringing that out, that could be the quadrilateral. Okay, doesn't look it, but it could be. Right, so all those sides are equal. Now, what do I do here? Well, I have to choose 2 points here, because these, I can make triangles out of them. Okay, so I'm looking at the points, but I can pick really any 2 points. Okay, it doesn't matter which way you look at it, whatever point you pick, whatever 2 points you pick will correspond to a triangle. Okay, did you get what I'm saying there? So if you pick this one, that corresponds to those. So all you need is 2 points. Okay, and you find your 2 points, you get the area. Okay, so you get the area, you put it into half of, so I'm going to label my points x1, y1, x2, y2. Okay, so I've got half of x1. x1 is 4. x1, y2 times 3 minus x2, 2 by y1, which is minus 1. Now, because it's a quadrilateral, it means it's a double triangle. So, I mean, I don't need the half. I multiply this out and it becomes 1. Do you follow? Okay. So you get that. So I'm multiplying it by 2. 2 halves is 1, right? Because it's actually, in other words, I'm just getting rid of it. So I'll just explain that again. 2 times 1 is 2. 2 over 2 is 1. There's no need to put the 1 there. Okay? So this is giving me the area of the parallelogram. And I sort this out, and this works down to 4 3s is 12, minus plus 2, good. 12 plus 2 is 14, so that's 14 units squared. Okay? So that's how you deal with parallelograms or anything, or quadrilaterals, any of them like that, you know. Pick 2 points because you've got one of the vertices 0, 0. If you don't have one of the vertices 0, 0, and I'm going to put this one down actually, if you don't have one of the points of 0, 0, you have to translate them all again to a 0, 0. Okay? So if I was given a set of points, for example, this is interesting, 4, 3, 1 minus 3, minus 2, and 1, 4. Now, say that's out there somewhere. Okay, say it's out there somewhere, there's a couple of minuses in there. Okay, so I want to bring then this to 0, 0, and they all follow suit. Okay, they're all following suit. So so you bring one of these to 0, 0. Now I'm going to bring the minuses to 0, 0 because then it'll bring everything up. So I'm going to bring that to 0, 0. What happened to the x? The x from a minus 2 to 0 went up 2, so up 2. And what happened to the y? It went from minus 2 to 0, so it went y plus 2. Okay? Now remember, you're going up or down, you can use plus or minuses. I prefer to use either, you know. So they all follow suit. So what happens to the x? It goes up 2, so that's 3. What happens to the y? It goes up 2, so that's 6. Okay, 3, 2, 2. 1 goes up 2, becomes 3. 3. Minus 3 plus 2 is minus 1. Okay, and we do 4, 4, 3 as well, if we want to. So 4, 3 up 2, 6, and then y is up 2, which is 5. Now you see then, now we have one of the vertices at 0, 0, so I can pick any point I want. You can pick those 2 points because they're positive. You're not dealing with negatives, and you can call that x1, y1, x2, y2. This is the beauty of coordinate geometry. It really gets everything into perspective, you know, and you know, a lot of plans can be moved around, and you know, a lot of forecasting can be done through the dynamics of coordinate geometry. As I've explained, you've now worked out the area of something by just visualizing it and changing its position. Okay, that's great. Now try and do as many questions as you can. Let's have a quick look at these questions. They seem to be okay. This is by translation of the vertices, and this is, you've already given 0, 0, so you just slot them in. Okay, there's a few minuses there, you know, so be great then. That's great. Thank you very much.